So now that we've finished the first module where we laid out the principles of neuroplasticity, we talked about the ways that we define it, the ways that we measure it, some examples of experience-dependent plasticity. We then dove into the behavioral signals that drive plasticity and the neural signals that drive plasticity. And now this is sort of where the rubber meets the road. That was in order to prepare you for Module 2, where we're going to try and apply our knowledge of neuroplasticity from Module 1 to the treatment of dysphagia. So what do we need to know to treat dysphagia? Well, if you think about it logically from a systematic approach, from an engineering approach, if you will, the first thing you need to know is, well, what is the neural control of dysphagia? How does the brain and the brainstem and the midbrain areas, how do those control function in swallowing? And as you'll see, swallowing is very complicated, and it requires a large number of neural areas and neural circuits to control it. We also need to understand something about the biomechanics. So what are the anatomical features that describe our swallowing mechanisms that allow us to make a successful swallow? So we need to understand the neural control, the biomechanics, the anatomy, and then we need to understand something about the causes of dysfunction. What are the sorts of things that can go wrong? Neurologically, in some cases, structurally in others, as in the case of tumors, etc. What are the sorts of things that cause dysfunction in dysphagia? Then we need to understand if there is dysfunction, what are the substrates of improvement? And that's where neuroplasticity comes in. There are obviously surgical manipulations for the biomechanical issues, but what about adjusting the neural control? And again, that's where neuroplasticity comes in. And so the first module was to give an understanding of how neuroplasticity works, what are the substrates, what are the signals that drive neuroplasticity. And now in Module 2, what we're going to do is talk about the biomechanics. What are the major structures involved in a normal swallowing response? Then talk about the neural control, the cortical and subcortical areas that are involved in controlling swallow. And finally, we're going to talk about the causes of dysfunction and some potential solutions to those issues. Our first lecture in this module is going to be on looking at the anatomical substrates of swallowing, the biomechanics of swallowing, if you will. So we're going to answer the questions, well, what are the basic oral motor structures involved in swallowing? And what are the basic stages of swallowing? As it turns out, it's very complex. So swallowing sounds simple, right? It's something that we do every day. It's a very simple procedure. All you're trying to do is propel food down from your mouth into your stomach without blocking respiration. That initial process takes about 2 seconds, another 10 to 15 seconds to get it down into the stomach. And we do it 600 times a day. In fact, for those of you that are interested, we secrete 1.5 liters of saliva every day that you're probably not aware of. However, swallowing is not simple. In fact, I would argue, being somebody who studies upper extremity for the most part, is very complicated. Success requires the coordinated activity of, depending on who you talk to and who you read, at least 32 pairs of muscles in the mouth, the pharynx, the larynx, and the esophagus. It's orchestrated by multiple cortical areas, basal forebrain, pontoon, and in addition, medullary areas. And it involves 5 and possibly more of the 12 cranial nerves that are out there. So it is a very complicated process that occurs across a very short period of time. So it's complex movements involving both voluntary and involuntary movements, and we'll talk more about that when we get into the neural substrates of swallowing. The voluntary, or the oral phase, is controlled by cortical and what we'll call supramedullary brain regions, and we'll get to that in the next lecture. The involuntary portion, which is the pharyngeal and esophageal phases, are controlled mainly by the cranial nerves and the swallowing centers that are located within the pons and the medulla. So when you start looking at the number of anatomical structures and the number of neural circuits that are important for the control of swallowing, the number of sources or possible places of error are numerous. And it's not surprising that the vast majority of neurological disorders involve dysphagia. So let's look at the biomechanics of swallowing. And it's basically a series of valves and a series of cavities. And the interaction between those valves and those cavities has to be coordinated just right in order for a successful swallow to occur. So first of all, there's the nasopharynx, which is part of the nasal cavity, which is located sort of directly back from your nose towards the back of your head. There's the oropharynx, which is slightly lower. It's just back from where your tongue is located, the back of your mouth. And there's the laryngopharynx, which is the sort of borderline between the pharynx and the esophagus. So those are the major cavities that are there that have to be coordinated. Then we have the soft palate. And the soft palate's job is to block any kind of transfer of fluid or food from the oropharynx into the nasopharynx. So for those of you who may have been out for a drink with your friends and someone says something incredibly funny and you're taking a sip of your beer and you spit it out your nose. Well, that's because the soft palate didn't have time to close and didn't do its job, and the fluid got into your nasal cavity and came out your nose. The other important structure, of course, is your tongue. Your tongue is the mechanics. It's doing the heavy lifting. It's forcing the food back towards the bottom of the back of the throat, forcing it down into the laryngopharynx so that you can get into the esophagus. There's the epiglottis, and the epiglottis serves a very important function, which is to block off the trachea from the esophagus so that when food passes down through this area, makes it through the mouth, it blocks off the trachea, allowing food to enter the esophagus and start the esophageal phase of swallow. And then, of course, there's the trachea, and that's where we don't want food and we don't want water. And the coordinated activity of these structures that I'm showing you right here are all designed to keep food out of the trachea and into the esophagus. So it's a fairly complicated system because we're using it for breathing, we're using it for speech, and we're using it for eating and drinking. And finally, there's the esophagus, which is the end point of the swallow, which is trying to get the food down into the stomach through the esophagus. So the biomechanics of swallowing. Now, depending on who you talk to and who you read, there are several different phases of swallowing. The first phase is the oral phase. So that's when you place the food in your mouth and you start chewing it. So mastication, your muscles of mastication. And that is during that time, your tongue will form a posterior trough, a curl rather, that will try and force the food towards the back of the throat. And so that posterior bolus, whether it's water or food, is being forced back towards, out of the pharynx, back down in towards the larynx area, and hopefully not into your trachea. So that's the oral phase, unless you're eating Oreo cookies. The pharyngeal phase, this is the closure of the nasopharynx by the soft palate and the opening of the auditory tube. The next phase is the closure of the oropharynx, and that's done by the tongue. And it's the opening of the eustachian tube, which equalizes pressure between your inner ear and the cavities located within your mouth. Then the laryngeal area is closed with the epiglottis, and that's, of course, to keep the food from heading into your trachea and heading down into your esophagus. And the hyoid bone also elevates, which opens the esophagus. What's interesting, some interesting hyoid bone trivia for you is of the 200 plus bones in the body, it's one of very few that's not actually connected to other bones. It's floating there. And it's there to open the esophagus and keep food from getting into the trachea. And the tongue, again, the heavy lifting part of the swallowing, is forcing the bolus back down through the pharynx into the esophagus. The esophageal phase, so if everything goes right and we've got no food heading into the trachea, the food is then, or the bolus is then sent down into the esophagus, and the lower esophageal sphincter will open and allow the bolus to enter into the stomach. And that prevents regurgitation of food back up and through the esophagus and back into the mouth. So those are the basic biomechanical or anatomical structures, the basic cavities that are there, and the basic valves, if you will, that must be coordinated in just the right amount of time so that food can move back through the mouth, not into the nasal passages and not into the trachea, and get it down into the esophagus, where peristalsis can then force the food down into the stomach and open up the lower esophageal sphincter so that a normal swallow can occur. So that's the mechanics of it. That's the anatomy of it. What we're going to do in the next lecture is talk about the neural control. What are the neural systems, both cortical and supramedullary, that control the movements of all of those muscles that are controlling the valves opening and closing and the peristalsis, et cetera, so that we have a successful swallow.